Hi gents, we're going to continue with moment of a couple. So we're going to have a go at exercise 4 now, and that way you can have a go at exercise 5, 6 and 7 after this example. So the question asks us find the force F for equilibrium. So it's basically saying once you've found F, that seesaw will now be placed into equilibrium. So you have right now you have a vertical force of F pushing down, a distance of 2 meters. That seesaw point is called A, and if we wanted to, this question doesn't ask it, but that is where we'd find the moment about A. You then have 2 meter distance, a 40 Newton vertical force, 4 meter distance, and then a vertical 30 Newton vertical force. So the question asks us find the force F for equilibrium. So we actually need to find that F there. So let's have a little go. So the first thing we want to start with is we can start with the moment around A. So that's our point there. So we want to start with that with a positive symbol. Okay, is equal to. Now we just want to go through and place in our formula. So we have 3 forces. So we want to add in that formula force times distance. Okay, plus force times distance, and yet placing that in 3 times because there's 3 forces. That's correct. Okay, that's good. Now we want to go through and work this out. So we add in our sign here. So our first force is F, right? From that point it's pushing down, so that would be anti-clockwise. So that first one would be negative F multiplied by the distance from that point, which is 2 meters. Okay, so we add in 2 plus our next force is 40. Now from that point it's pushing clockwise, so it would be positive 40. Now a distance at 2 meters from that point again, so it would be 2. And our final force is 30 newtons, again pushing down, so it's pushing clockwise, so it'd be a positive 30. Now the distance from there is 4 meters plus 2 meters to get back to that point, so it'd be actually multiplied by 6. Okay, so now we have our working. Now the biggest problem from here is that that's a negative and we need to move it to the other side, so it's a positive. So first thing we need to do is we need to write in F multiplied by 2. Now it's made that a positive because on the opposite side the equal sign. You then can go through and work this out. So it's 40 times 2, which gives you 80. Okay, so you can add that in, 80. Plus 30 multiplied by 6, and it's still positive, so it'd be plus 180. Okay, so that's where we're going with next. Now you want to try and break this down a bit further, so we want to get F by itself. So you go F times 2 divided by 2, so that way F's isolated, multiplied by 80 plus 180 is 260. Divide that by 2 because you did it over here. That should then leave you with F isolated, and that gives you a positive 130 newtons. So F, as we said in our question up here, F is worth 130 newtons. Now by doing that, you've now placed that seesaw in equilibrium, because that's what our question just said. Once you've found F, that seesaw will be placed in equilibrium. So there you go, gents. Have a go at exercise 5, 6 and 7 on page 72 and 73. Okay, and our